Let's take a very welcome break from all of that really difficult math and just look at some linear inequalities. So you may or may not have done this in previous classes. Some people find this very easy. Some people really struggle with which way to shade. So let's take our time through this. When we're solving linear inequalities, we're essentially graphing just like we did on a number line. So let's recall back before it was two-dimensional with an x and a y. If I said x was greater than 3 on a number line, we had to choose at 3, did we put an open or closed circle? And this would be open because there was no or equal to. And then we wanted to shade in the direction of all of the values that were greater than 3, like 3.1, 4, 97, etc. So that's what I did one-dimensionally. Now I have two variables, and I want to do the same thing. I want to essentially graph and shade the entire graph of points that would work into this inequality. So just like before, if I have a greater than or less than, before I used an open circle, now I'm going to use a dotted line because I'm actually drawing a line, not a point. And if I had an or equal to, before I used a solid circle, now I'm drawing a solid line. And then we'll talk about which way to shade in a moment. So what I want to do is I want to start graphing this like I normally would. This is in slope-intercept form, so I would start at -5. I would use my slope of 2 to go up 2 over 1 as many times as I need to. And the trick here is make sure your graph, your line covers basically as much of the graph as possible. And instead of connecting with a nice straight line, I'm going to connect with a dotted line because it's not or equal to, so I'm using a dotted line. So I'm connecting right here with a dotted line. Now I either want to shade everything on this side of the line or everything on this side of the line. And how do I choose? Well, the easiest thing to do when you're just getting started is choose a test point. So choose a point that is solidly on one side of the line. So don't choose a point like 2, 2, because that's really, really close. I'm going to choose the point 0, 0, because that's the easiest test point to choose unless 0, 0 is on your line. And what I mean by test point is let's replace y with 0 and let's replace x with 0. And do I get a true statement? 0 is greater than 2 times 0 is 0. So 0 is greater than -5. Is that true? Is 0 a bigger number than -5? Yes, it is. If it's true, the test point should be shaded, which means everything on this side of the line is shaded. Everything on the left or the right is not. Everything on the left is. The other way that you can think about this, and I caution you, please listen to this warning. This only works when you have y first. If I have y is greater than, let's look at the y-axis and find all the points greater than this. They would be up here. And so notice I've shaded in that direction of my line. If that second way didn't make sense to you, this guy always works. So just use that guy. Let's try a couple more. These should be pretty straightforward. X, if this were an x equals 3 equation, remember I would go to where x is 3. I would draw a line this direction, so that's what I'm going to do. But I'm going to make it dotted because it's an or equal to, so not solid. And then again, I can choose a test point. 0, 0 is my favorite test point. 0 for x, there is no y to plug it into. So is 0 less than 3? Yes, that is true. So 0 should be shaded. So everything on this side of the line is shaded. Same thing for the other one. Y is greater than 4. So I'm going to go to where y is 4. This time it's a greater than or equal to. So I get to draw a solid line like normal, not a dotted line. Choose a test point of 0, 0. 0 is greater than or equal to 4. That, unfortunately, is false. So don't shade towards 0, 0. Shade the opposite side of 0, 0. Let's look at two more together. Hopefully the graphing part is super easy because we've graphed a lot in this class, and the only part you're maybe struggling with is the shading. So for my first guy here, remember this is like y is less than 4x plus 0. So start at 0, use your slope of 4, up 4 over 1, or down 4 to the left 1. Make as many points as you feel comfortable with. Connect these with a dotted line because it's or equal to. Do the best you can. And then choose a test point to help us to know which way to shade. Again, if you're comfortable with this shading, and notice y is all by itself, I can use that little trick that says where are the y's less than. It's all the guys down here, so I'm shading this side. But if that part's confusing to you, then let's choose a test point. Now this one's a little bit different because I can't use 0, 0 as a test point because 0, 0 is right on my line, so don't use it as a test point. So choose another random point. I'm going to choose 7, 0 as my test point. So I'm going to use 0 for y, 7 for x. I get 0 is less than 28, and that, of course, is true, which means 7, 0 must be shaded. So I would shade everything on that side of the line. My second one, this guy is not in the correct format to use that little shortcut trick. So you have to use a test point or turn it into slope-intercept form properly. You choose which way you want to do it. I'm going to choose to graph this using that cover-up trick. So x would be 2, y would be -4. Oops. That's kind of a confusing little numbering system. -1, 2, 3, 4. I was in the right place. This guy is a solid line because it's or equal to. Do the best you can to make a straight line. And again, I'm going to choose a test point because I think that's the easiest way to go. 2 times 0 minus 0 is greater than or equal to 4. 2 times 0 is 0. 0 minus 0 is 0. So I have 0 is greater than or equal to 4. Is 0 greater than or equal to 4? No, it's not. So 0, 0 was my test point. It was false, so 0, 0 shouldn't be shaded. So everything on this side will be shaded. Notice, again, I could not have used that trick because y was not by itself. Here are two guys for you to try on your own, so press pause, graph them both, make sure you choose the correct direction to shade, and then press play to see how you did. So for my first one, I am supposed to go through at 0, 0. My slope is 2/3, up 2 over 3, up 2 over 3, or down 2 to the left 3, and continue with that process. And this guy is an or equal to, or is not an or equal to, so it's dotted. Y is on the correct side, so if I want to use my shortcut, I can. Where are the y's less than? Y's less than are down here. If you hate that trick, use the test point. I can't use 0, 0. Let's use that point of 7, 0 again, just for fun. Oh, let's not do that. Just kidding. Why wouldn't I want to use that? Because I wouldn't want to take 2/3 times 7. Let's use the point 3, 0, because 2/3 times 3 is easy. So 0 for y, 2/3 times 3 is like 2/3 times 3 over 1. I get 0 is less than 2. True. Everything on this side gets shaded. Next question. Again, I'm going to use the cover-up trick to graph it. Cover up 5y, I get x is 5. Cover up 2x, I get y is 2. Connect those dots with a solid line as best you can. And then choose a test point. I'm choosing the point, surprise, 0, 0, because it's the easiest one to choose. So 2 times 0 is 0, plus 5 times 0 is 0. 0 is greater than or equal to 10 is absolutely false. So 0, 0 shouldn't be shaded. That means the opposite direction is shaded.